All right. My name is Kevin. You all just met me. And today I will talk to you about two things. The first thing I'm going to talk to you is level up your game dev workflows with DevOps practices. So before we start, I'm going to tell you a bit about myself. I just introduced myself with my name. I'm Kevin Hagen. And as Linus already has said, I'm working at Freaks, and there I'm working as the CTO and gameplay programmer. So far, I have 2 shipped titles on my list. Those are Battle Planet Judgment Day and Unsung Heroes: The Golden Mask. I also do have a university background. I did study a computer science related field. And then I directly started working at Freaks afterwards. So let's look at what I brought with me today. First, we will outline the underlying problem that we are trying to solve. Then, in order to solve this problem, I will introduce you to DevOps. And in order to delve deeper into the topic, we will look at some DevOps practices. Namely, we will look at workflows, testing, a thing called CI/CD. We will hear about it later, and metrics and monitoring. After that, we will finish the talk off with some closing words. If you have questions in between, I would kindly ask you to save them for later. I tried to allocate some time for questions at the end. Let's see how this works out. All right. Without further ado, let's start with outlining the problem. So we are all game developers. And as game developers, we are kind of living in our game dev wonderland because we want to make games. And luckily, games are software, and software development is iterative and agile. This is good for us and fits our wonderland very well because iteration is key for games as well. If we want to make a great game, we have to work on a lot of iterations, implement our features step by step, and work ourselves from start of the production to finished and released games. Now, in order to finish such a software product, there are multiple models that we can apply to our workflow. One of them is the quite old Waterfall Model, which luckily is outdated already. In the Waterfall Model, I assume most of you have already heard about this. At the beginning, we have our requirement analysis, which is used to just write down the requirements of our software and the systems to be developed. Then we have our system design step. In that, we will specify what we need and prepare the design of our systems. In the next phase, we are finally getting to implementing them. And this is the first time where we start developing our systems in smaller units to form the game in the end. Afterwards, we get to the integration and testing phase, where our developed units will finally be tested, and we look at how the game works and if there are still any bugs or not. After all this has been done, we can finally deploy and ship our game. And once our game is shipped and ready to be played on the customer's machine, we get to the maintenance phase, where we eventually might release a patch or something. Each step in this model goes down, flowing from one step to the next, like a waterfall does. This is why this is called the Waterfall Model. Now, eventually, we might also get back to the beginning of the requirement analysis for the next product lifecycle or whatever. Usually, in the Waterfall Model, this isn't the case, however. The disadvantages of this are quite apparent. Our software is only produced until very late in the process, so we don't have working software early on. And this introduces high amounts of risks and uncertainty, and for complex software like games, this is simply not a good applicable model. So luckily, smart people invented a new thing, and this is called the Agile Development. You probably also heard about this already. And in the Agile development process, we do have basically the same steps. The only difference being is that these are kind of reordered now, and we are going in a circle from requirement analysis to system design to implementation to testing to deployment to maintenance. And then we call this thing our first iteration. And we proceed with the second iteration, which, who would have guessed, looks exactly like the first iteration. The same steps applied over and over again, but in a faster way after each other. And after that, we get to the third iteration, and so on and so on. Now, let's go back to our game development wonderland. And thanks to these agile methods, we are now extremely lean and fast. Or are we? The sad truth is there's a crushing reality behind all this that I see in a lot of companies and that happens in a lot of companies. Things like bug fixing and optimization are often postponed until very late in the development process. So we keep developing our game, and months into the production, we first finally find time to start fixing bugs. Each time that we don't test our game, and we won't test our game for quite a lot of time throughout development because we want to develop it, will introduce new bugs into our game. I bet all of you know this. If you don't watch your game for at least a day, there are suddenly new bugs appearing. Deploying your game usually is a hard, error-prone, and often even a lengthy process. Depending on the target platform that we work with, this can mean that we need to do stuff like app signing, for example, for Apple development after we build the app. And then we have to upload it to the App Store and go through all the manual processes. These processes, depending on the platform, can take 1 to 2 hours or even up to days. Doing this most often is really hard. And as I said, as there are many steps involved, these steps are often error prone and you can fuck up a lot of things throughout the process. And then maybe you even have to redo everything that you did so far for the deployment. This in turn leads to a pretty high turnaround time, which means from the time where we start working on a change, it takes a lot of time until we finally have the change in a finished deployed build. And on the other hand, this also leads to rather small change volume, meaning from one build to the next build, we usually include only small changes because we are busy making builds. This leads to something that we see quite often in games, being huge day one patches, for example. Of course, there are multiple reasons to that, but this definitely is one of them. And to game development being full of crunch, and especially for game development being famous for being full of crunch. And that definitely is something that's not cool. The other bad thing that goes kind of hand in hand with this crunch situation is that we oftentimes have to pull off heroics and miracles in order to get the shippable or releasable game finished in time. And I think we can all agree that this is a suboptimal situation. We will now look at 2 problems in a bit more detail. The first problem is working in large chunks. So imagine the following situation. We have 2 developers on our team. The first developer writes some code on file B. They add a few lines of code, they remove a few lines of code, and so does another person on our team on a different file, maybe, or maybe it's even the same file. Eventually, they have to put all their changes up into version control of whatever we are using, and this leads to us having to somehow merge these large chunks of work. And as we all know, merging larger chunks of work or even smaller chunks of work often is complicated and leads to conflicts. Conflicts, in turn, lead to our small friends that we refer to as bugs. And unfortunately, it often leads to a lot of them. So what we want to avoid is having a lot of these merge conflicts. The problem here is that the work is not properly split into small chunks of work. And developers often tend to work in isolation for too long, whether this is on a really isolated branch or just on their local working copy doesn't matter. What matters is that we are making a lot of changes without reintegrating. This leads us to a step that we refer to as merge-shell. It's called merge-shell because merging sucks and merging can be very complicated. As you've just seen, merge-shell leads to defects, and defects will always get us to bug hunts. And all these notorious bug hunts somehow always lead us to new bugs, and those lead us to merge-shell again. To me, this sounds pretty alarming, because if we look at this, this is a kind of never-ending circle. And what this leads to is one of those, a few of these red flags that we desperately try to avoid when developing games. The first one being buggy games, which in turn leads to another red flags, unhappy customers. And I guess none of us want unhappy customers. What's even worse is that this directly affects our developers, and this leads to continuous crunch. And continuous crunch very quickly leads to stressed out developers. Now, in fact, there's even a second problem, and the second problem I referred to as the Agile Waterfall. So this is kind of a shipped word between the two models that we saw in the beginning. At the start of such a process, we usually have an idea or plan out a feature set, and then we hand this to our developers. Our developers write some code, do some changes on the existing code base, and without noticing, they somehow break a thing. They introduce a new bug. They simply don't notice. We keep writing new code and we proceed with the development, and eventually we get to a phase where we stack up more and more bugs, and our haystack, our technical debt increases with this time. Eventually, we will get to playtesting, and in playtesting, be it internal or external, we get some report back to the developers, and then the developers start fixing all these bugs, and we give that back into the QA and playtesting session. This circle proceeds until we finally addressed all the technical debt and fixed all the bugs available. Often at the end of this process, we have exhausted developers that went through super exhausting bug fixing phases for days, weeks, or maybe even months. And this is something that we hear of in the industry almost every single day, be it a small or a bigger company. Luckily, once we fixed all the technical debt, we can finally deploy our build. But what's really bad about this is usually we've already broken something different that we haven't noticed yet. And then this circle continues over and over again, but over a longer period of time. And this longer period of time really is the problem here, because this leads to kind of continuous stress in the development team. What we are doing here is we're pretending to be agile. In truth, the waterfall still has each phase applying in the same model that we are working after, but just the whole execution of the waterfall happens more often. What we do is we silently carry on from one waterfall iteration to the next, jumping from milestone to milestone. So basically, what often happens is game development works from one waterfall iteration to the next waterfall iteration, going from alpha submission to beta submission or whatever. We are kind of applying our agile tools here, but we're not applying the agile mentality. And this really is a problem, because who would have guessed this kind of leads to the same red flags and issues that we had before. And note how I even swapped out merge shell for work hell here, because really work has become a hell at this point and just isn't enjoyable anymore. Here are a few reasons why this sucks and what the underlying problem of this really is. We often have slow verification processes for everything, and those verification processes often involve too many people. Building a new thing and then finally verifying it takes a lot of time. The turnaround time is way too high usually for what we are working on. And then verifying that we didn't break anything else of what we've worked on previously takes even more time. The problem here is that we are often relying on manual testing only. Of course, not everybody does this. Some people do this crazy thing called automated testing, but many of us don't. This has some implications, being programmers who require other people's time to properly QA features. I mean, we programmers can of course QA and test our features, but you all know programmers who say this famous sentence, "It works on my machine." And proper QA also requires a huge detailed and understandable Excel sheet, because if we don't have such a detailed Excel sheet, then testing our game properly is a mess because we don't know what we're actually supposed to test. And following these Excel sheets and test instructions always requires like 120% of our concentration all the time that we're testing, which obviously is just not doable for a normal human being. This results in milestone approaches often resulting in complete feature stops, because all we have left to do now is fixing bugs and getting the game shippable. This prevents new code features for multiple days, maybe even weeks, who knows, depends on the team size and processes involved. And now we suddenly need to reduce the technical debt that we accumulated over months to a shippable level, quote unquote shippable level, because in the end it will still be there. It's just smaller, hopefully. And this often leads to huge stress, crunched and or even delayed submissions. And none of us wants delayed submissions because maybe milestone payments are directly connected to it, and without the payment we can't further finance our company or whatsoever. Another bad thing that is included here is that we often have the tendency to merge a lot of changes right before submissions. So beta milestone is right around the corner, and finally we realize that we have to integrate all the art assets with all the code changes that happened over the past few months. And of course this is an extreme example, but still these things happen again and again as we go to milestone submissions. And the core problem is this ain't as agile as we think it is. Deep down, this is still a waterfall model, which is just applied milestone to milestone. We are usually working from planning to development to testing to deploy to maintenance all the time, and there's no time for breathing in between. What we are doing here is we are completely ignoring both keep it working and testing is not a phase. Both these things are usually postponed until the end of the development process or milestone submission or whatever. In the meantime, to most of us, it doesn't matter. Most of us probably don't even know if their game is in a buildable state at the current time. And this eventually will lead to continuous crunch instead of continuous delivery, which is really bad. Luckily, these problems are quote-unquote easily solvable, and in fact traditional software development solved them for us years ago. It's just that game development somehow hasn't caught up with this. If you want to know more about the underlying problems and also have a different input other than mine to this topic, I highly recommend you to watch Seth Costa's talk. He does a phenomenal job on also explaining all the problems and the issues that lead us to this agile waterfall kind of thing that I just described, and why we desperately need DevOps practices. And he also does a great job on explaining DevOps in more detail. So if you're interested in this topic after my two talks, then check this out as well. Now, let's finally introduce DevOps to see how it can help us. DevOps is the practice of operations and development engineers participating together in the entire service lifecycle, from design through development process to production support. what does that mean? What are development engineers? What are operations engineers? Development engineers are concentrating on building the product. So they are the ones that we commonly refer to as the dev team. They implement new features, build new assets, and so on and so on. And the operations team, at least mid-sized to large-sized companies have such a team. They take care of actually shipping and deploying our product. They keep our game servers alive, they monitor stability and things like that. So in small teams, these are often the same people, which kind of can be beneficial for our DevOps workflows. What DevOps does is it focuses on the interoperability and the relationship of all teams involved in the product lifecycle. It does not replace agile practices, but it rather serves as an addition to them. What DevOps really is can be split down into at least 3 parts. There are extremely various definitions on the internet, and there's no one scientific correct definition for this, but it involves a few parts that are always the same or that each definition kind of has in common. Those are the culture. So DevOps is a mindset of continuous learning and improvement. There's no time in the whole process where you've finished with your DevOps journey or where you finish with your product or the workflow improvements or whatever. Then we have tools and stability, and those basically aim to streamline our workflows. The third thing is the communication part, which tries to tighten and amplify our feedback loops so that we have quicker feedback on whether or not there are bugs or breaking changes or whatever in our development. And one of the most important practices or mantras in DevOps is that if there is a painful process in our development cycle, we should do it more often, not less. Because if we don't do it, we can't fix it. We won't learn how to address that issue properly. And if we do it at least every day or even multiple times each day, then we will learn how to tackle this problem and we will learn how to do it in a timely fashion. And in fact, to most of these problems like painful deployment, there are even tools available to us that make this extremely easy if you just put in some time initially. And this will save you a lot of time throughout the whole development process. So let's have a look at some of these practices. Most of these things that I will present to you now are basically methodologies and tools that you can apply to your workflows, and that all are living up to the DevOps mindset that I just presented to you. So if you apply some of them already, you're on a really good path, and if you don't, then you hopefully can pick a few methods up here that are easily to apply to your workflows too, and that will be beneficial to them. The first thing is rather a requirement. What you need for embracing the DevOps mindset in your team, in your company, is a good agile basis. So if you're not doing that already, start working in sprints. This will immediately help you chunk down the work and work in smaller ticket packages and so on. Do things like daily stand-ups, have the information flowing. Speak to your team members and see what you did from yesterday to today, or if you can't afford to do it on a daily basis, do it at least weekly or something. Then you should also introduce meetings for sprint review and planning, etc. So basically, to sum this up, you should at least roughly follow some agile methodology, whether this is Kanban or Scrum or some homebrew process that you find best suitable for your workflow. Doesn't matter, but there are extremely valuable nuggets in these methodologies, so pick them up. And the good part is this is actually industry standard. So if you learn all this during your studies, you will be well prepared for working in the professional industry. And this is not only industry standard, it will also help you in various parts throughout development. You will be better managed and you will have a better grasp of what you can do and what you can achieve throughout the development of your project. Next is our bug or issue tracker. This kind of goes hand in hand with the previous process, because if you start planning sprints, you will somehow need a tool to track your bugs and issues and tasks that you have in your sprints. This is mainly used to manage your project and chunk it down into smaller parts of work. It will also help you keep track of your progress, and of course this helps you to gather tickets and bug tickets and so on. If you haven't heard about this yet, the bare minimal implementation, so to speak, that you should have is a backlog, a sprint list, a review list, and a done list, where in the backlog you have all your tickets that are still required to be done sometime in the future. The sprint is the work that you are trying to currently address. The review deck holds all the tickets that are kind of done but not QA'd yet. And then in the done list, you can see what you have achieved in the current sprint. And the good part here is we can connect this with our DevOps mindset of getting rid of hard manual labor and instead automate some of these workflows. For example, we could find a system that helps us automate the creation of new tickets, because maybe we have something that we can integrate into our game even, and I just can make a screenshot of whatever has just happened or a video and submit it with a small text, a few keywords, and those automatically get turned into a ticket in our ticketing API, in our ticketing system. Some of the systems that you can use are Jira, Trello, Notion, or Codex. We personally just moved from Jira to Codex, and we really love it. So if you don't know about Codex yet, I highly recommend you to check it out after this talk too. Next up will be our source code management. And if you're not using any kind of versioning, then please do it, because come on, it's 2020 and there's no excuse to send files to your teammates using Dropbox or something. This is insane and you can't live with that. If you do, you will find switching to version control extremely nice, because we have benefits like branching and other stuff. And what is even more crucial if we talk about DevOps is the role of our source control management system in our continuous integration server, because our version control system can notify a build server every time somebody on the team commits, and this build server then can create a new build automatically. We will actually look into this in a more detailed manner in the next presentation, and we will also hear a bit more about this throughout this talk. The next thing this helps with is actually checking in changes in small chunks of work, because making a commit is extremely easy. Sending your code files via Dropbox to a colleague is a rather painful process. If you haven't heard about this yet, there are various tools available for this, some of them being SVN, Perforce, or Git. Now, all of this isn't really technically DevOps, but you kind of require this to start embracing DevOps workflows. The next thing on my list are code reviews, and this is really something that is all in the mindset of DevOps. If you're not doing them yet, start implementing some kind of formal review process. It can be on a daily or weekly basis or whatever. This will, first of all, ensure higher code quality and standards, and you will automatically start catching defects early on. And this is the whole thing that we are trying to do here. If I send my code that I just checked in to a colleague and they have to look at my code, they will probably find this nasty null reference check that I just missed. And doing so, they luckily just fixed the defect that otherwise would have made it into production. If we don't have these code reviews in place, nobody will notice that I missed that null reference check, and suddenly the game breaks. And maybe this is even happening in an early on level, and then the whole game isn't playable anymore, which really sucks. Another good part about code reviews is that they actually help sharing knowledge between multiple team members, and this definitely helps with the communication in the team. And of course, this also kind of keeps the bus count low, because if all my colleagues always know what I checked in and they look at my code in these code reviews, if I'm run over by a bus, this still doesn't make me happy, but at least my company still knows how to work with my code. Yeah, and as I've just said, code reviews really help catching slippery mistakes early on. And overall, this simply reduces the error rate that you have in your project, and even the error rate that you have on your production code. This can be a live project or a project that simply is currently in development or whatever. The tool that we use for this is called Upsource. Upsource is being developed by JetBrains. They also made the Rider IDE, so you might be familiar with them. And if you are familiar with Rider or other JetBrains products, then you will find yourself really at home with Upsource, because they, as always, did a phenomenal job on making a nice user interface and making the whole review process very usable and simple. This is roughly what it looks like. You can write comments inline into the code. Everybody can be added to making a review, and then they can accept the review or make some notes on it and say, hey, maybe we should change this, or hey, I think this has some implications that you didn't think about, and so on and so on. So this is just a nice way given to us that helps us to finally start having conversations about code if we don't already. Another part that definitely helps with knowledge sharing is having a company or at least a project wiki. Knowledge sharing is key if we want to make resources accessible. And this really is something that happens in a lot of development teams. You often see one team member going to another and asking, for example, for where to find this new asset. And if we don't have, maybe we don't even have an asset pipeline that properly exports the asset from, let's say, Photoshop to our textures folder in our project, and they just put it somewhere in the project, and we don't have guidelines. So now I want to implement that new texture, and what I have to do is, before I can actually work, I have to go to my colleague and ask them, hey, where did you put that new texture? If we have an export system, I will probably always have the same output directory of textures where I have to look at, and then I don't need to go to my colleague and ask, hey, where did you put that texture? Because I know it's in this texture folder that we set up specifically for this pipeline. And if I don't know about this pipeline, I would still have to go to my colleague and ask them, unless I have a wiki where all this is being written down and I can simply access this and read to finally see where I find all the stuff that I need. And maybe this is even more complex than just needing a new texture. Can be basically everything that might serve as a guide or a self-service system. So for example, how do I make a new build? This is something most artists on our teams usually don't know, but we can simply make a nice small guide and explain them how they can easily make a new build. At Freaks, we are using XWiki. It looks roughly like this. You have a navigation bar on the side. You have a content page that you can fill up with text. And it also has a nice, what you see is what you get editor. So this one is what we ended up with. And it also is free to use, apparently. So no pricing involved, which is nice. Next are some cultural things that we can implement into our DevOps practices. And if you don't have those already, those are things that you can easily start with. Start having meetings and write protocols about them, because protocols again also share with knowledge, help with knowledge sharing. As you grow, you will realize that you can't afford to have everybody in the team on each meeting at all the time. And to be honest, this also just isn't really, this doesn't really benefit the meeting. If there's 20 people in one meeting, then you won't get anything done. If there's 3 people in a meeting, you will still be fast and get to your goals. And those 3 people just can do a nice job protocolling everything. And then the rest of the team can read that protocol and make comments about this. Another important thing is that you should have some cross-disciplinary team time. This is something that especially we realized once we grew our company to more people. And something we did against this is simply implement a meeting that we have each Friday where we have everybody in the team sit together and recap what we have achieved throughout the whole week. So we have a small presentation where everybody can put in what they did, and we always have some nice GIFs and videos of the progress that has been made on the project. This is extremely useful to keep up to date with everything that has happened, and also extremely useful to see what your colleagues have made, because especially as you grow, it will be hard to keep an overview of what everybody has done. And one of the most important things is that you should incorporate a fix over feature mentality. So if something is broken, before you build something new on this, rather fix it first, because otherwise you will build shit on shit, and this will just stack up your haystack and will lead to an unmanageable project. For example, if we have a nice build pipeline in place and it somehow produces only failing builds, then the first thing we should be doing should be fixing this build pipeline and see what is going wrong, because otherwise we have a build pipeline that we could even suspend because it doesn't do anything really. And yeah, in the end, this helps us to keep the haystack small, or at least smaller. Next up is a slightly tougher topic, because this actually takes more time and is not as easy to implement as the aforementioned things. And this is testing. And in DevOps, we are especially talking about automated testing. Of course, manual testing also is nice, and you probably won't be able to fully replace manual testing by automated testing. But what testing can do for us is get rid of all the repetitive tasks that we are doing. So all the stuff that we so painfully put in Excel sheets and have to go through all the time using 120% of our concentration, we can let this be done by a machine, because a machine is usually way better at things like this. They don't need to concentrate, they can just follow instructions, which we can't that well. The good thing is, if we force our developers to actually write automated tests, we force them to think of edge cases when they write code for them. And this automatically leads to a cleaner and more stable code base. Speaking about automated tests, we do have unit tests. These check small individual parts of our systems. And then we have the integration tests to check bigger systems in our production. The best thing about this is that having an automated test suite in place that gets executed boosts the confidence of our developers in making a change. I bet all of you have heard a programmer saying, I don't know if I can change this, who knows what this will impact. And if they say things like this, then this is a very good indication that you need automated testing, because automated tests, they can simply be executed by clicking just one button, and they will automatically give you the feedback if something has broken. Because if a test fails, it means our game is now broken, and the change that I just made has introduced this breaking change. Unfortunately, writing tests does come with a cost, because we have to write them, it's more code. But as you can see in this graph, usually we start out a bit slower, But in the end, we become way faster because we don't have to hunt bugs all the time after we made changes, and changing things in the future is way easier because we have our test suite verifying that we did everything correctly. If we don't have an automated test suite, we usually start out very fast, and over the time we get really slow and rigid because we don't really know if we can change something, and if we change it, we are likely to have broken something in the game. And this then needs time to be addressed. Tests are usually run by pressing a single button, and they are ideally incorporated into our build pipeline. What if they fail? Our devs are immediately notified and see that something went wrong, and this in turn helps us to avoid rushed last-minute bug hunts. Okay, now let's talk about this weird CI/CD abbreviation in my presentation. The first part actually stands for continuous integration. And what continuous integration is about is working in small changes. It demands us to integrate with the trunk or the master branch on Git or whatever often. And most of the time we will have a continuous integration server that automatically fetches changes that we made and produces a new build of our game. In there, we usually have a build that at the end we have a build, and this build usually gets verified by an automated verification system. This system, most of the time, are the automated tests that we just spoke about. If something goes wrong in this whole process, our developers are being notified, and again, they immediately know that something went wrong and that they just now introduced a breaking change. Continuous delivery is the part that starts exactly where continuous integration has stopped. So continuous integration goes from making a change, committing it into source control, to fetching it on our build server and producing a playable build from that. Continuous delivery starts exactly there. We take this finished build and we automatically push it through our deployment pipeline to get it from our build machine to our target platform, for example, the PlayStation 4. The ultimate end goal here is to get the final build exactly one click away from deployment to production. So at the end of the day, we could simply press that button and say, okay, this build now goes live. And the go or no-go decision for updating the game, releasing a patch, having the beta submission today or whatever, now is finally being shifted from a technical decision because the developers say, no, we can't do this, there are too many bugs, to a management decision, who in turn can say, no, it's simply not the right time to release the patch today. But we could. And this is the important part here. The goal of this all is to make the deployment pipeline as safe and as fast as possible. So this is exactly what I talked about earlier when I said, if something is hard, we should do it as often as possible. And continuous integration and continuous delivery are doing exactly that. They are taking our changes each time we make a change, and they are producing a new build. And if we successfully do this, we are kind of at the end level, because each change directly ends up in a new build. We can look at this whole thing as a typical pipeline, and what we have then is a first phase where we start out planning a feature, then we write the code for it, we commit the code to our source code management system. The build server fetches these changes, produces a new build, and tests it. This is where continuous integration stops. Then continuous delivery takes in and uses this new build and pushes it through our deployment pipeline. Maybe we have some test servers, maybe we have some staging servers, and at the end there's our release server where we can finally deliver it to our live customers or players or whatever. And if we look at the whole process as one, we are calling this continuous deployment, which kind of is the end goal, the bonus to continuous delivery and integration. Continuous delivery means we can always release. Continuous deployment means that we do always release. So each time a developer commits a change to the trunk, to the main line of our repository, this change gets automatically deployed to our production servers with zero downtime. This is something that especially companies like Facebook or Netflix do. They commonly have this in their workflows, and they have incredible build stability, which allows them to actually do this. And also some game development companies do that. For example, Rare does that with Sea of Thieves. Each change that developers make almost immediately gets pushed from their repository to the production. So why should we go through all the hustle and incorporate such a continuous integration server? Because it avoids merge. We integrate often, we integrate fast, and we always have a testable / releasable build ready. If we don't opt to release it all the time that we have it, we can at least test it all the time. And of course, this helps us reduce deployment risk and makes this whole pipeline that I talked about way easier, because we simply have it in place. We have replaced all the manual labor that we have to do, clicking on build game in Unity, taking the exe, uploading it to our target machine. For Apple development, we maybe even have to sign the app file afterwards and so on. All these steps are being automated by our build server. And this helps us to detect bugs early on, because we have all our verification systems in place. If the build has build compile errors, we are notified immediately. If some test fails, we are notified immediately. Of course, we won't catch all the issues, all the bugs, but we will catch a lot of them, and we will especially have more confidence in making changes. It also helps others on the team to improve the sense of progression, because everybody can simply fetch the newest build and play it. And this in turn leads to regular user feedback, because everybody on the team can report back on the changes on a daily basis, for example. In the end, this leads to higher quality of our production cycle over time. So instead of having rather low quality throughout the whole development process until we finally release or have our milestone submission, we have a high quality all the time throughout development. The last part on the list are monitoring and metrics. There are a few things that you can track. These are, for example, code coverage if you do automated tests, build stability if you have a build server in place, maybe even build time, because you don't want to wait 4 hours each time until your build is finally ready after a change. And the one thing that's important here is that data is key, because if we don't have the data, we can do anything. If we do have the data, we can use it to take it and help streamlining our processes. We can then suddenly identify, oh wait, my build time from yesterday to today has increased from 1 hour to 4 hours. Something is wrong, I need to check this. And what's also important is that the data always helps us to identify bottlenecks. If we see that, for example, our build time has increased from one change to another drastically, then we know, okay, this is what was the breaking change, so to speak. If we see it always stays too long in the Unity build process, we know building the game in Unity takes too long. If we see uploading the game to the console or whatever takes ages, then we should maybe check on our internet connection or whatever. And there are, of course, even more obvious examples that we can use. And maybe we can even gather data in our team and use it to identify bottlenecks in our team. For example, we might realize that we actually would require a new programmer on the team, because all our artists are always waiting for their art assets being implemented. They output 3 assets or so per hour, but our developers only get to implementing 1 per hour. This means we need to somehow change the pipeline or somehow change the workload that's being managed by the people. And of course, we can also use our metrics and share them internally to maybe even brag about how awesome and stable our systems are and that we don't have any bottlenecks or something. A tool that you can use for this, or 2 tools rather to say, are Prometheus and Grafana. So we are using them internally as well. Prometheus is the backend, which serves as the database and collecting all the data. And Grafana is the tool that draws these nice graphs and visualizes them. And you could also now take these graphs and hang them, show them on a screen somewhere in your office so that they are available to everybody all the time, and that you can immediately see if your build time, for example, starts being too long, or your builds keep failing for some reason. This is something that you can easily visualize in such graphs. So now let's round up the talk with some closing words. DevOps is a set of practices, tools, culture, and even many more things that we can use to enhance our work. And as we've seen, it kind of is time for a change in game development. Traditional software development has done this years ago, and to be honest, there's no reason that should prevent us from doing the exact same steps and learn from what they've learned in the past. If we successfully apply all these practices, we get to avoid continuous crunch, and we start with continuous delivery. Instead of crunching all the time, we have a nice relaxed time where we can play our game all the time, whenever we want. Something a lot of people get confused, however, because this seems like a whole lot of work, is that this might be exclusive to elitist large-scale teams who have the money, the budget, and whatever. In fact, it isn't. We managed to pull it off, and we are a rather small team, and a lot of other teams who are even smaller than us also managed to pull it off. So what we can learn from this is that all of us can make this change if we want to make it happen. However, it is a process that takes time. I just presented to you a lot of new technologies and things that you might not have heard about yet, and implementing all of them at once is like a huge Hercules task that seems unfulfillable. But if we properly plan out our transition to adopting all these, then we can make this a really manageable task of work. And what is kind of like the most important learning here is that we actually lose way more time and money if we don't do these than if we invest some time to finally do this. Also, as we've seen, tools are important, but they are not the silver bullet. Just applying the tools won't help us, won't get us anywhere. We really need to embrace this DevOps culture in our team, and everybody needs to be on board with this. So it's usually a good idea to start out small and grow this big with the time. For many of us, a good starting point is a continuous integration pipeline, which is what we will look at in the next talk. And after we have this in place, we can delve deeper into the DevOps realm. Thank you for your attention, everybody. I hope we do have some time left for questions. If I'm not mistaken, we were on about 50 minutes now for this talk. So there should be 10 minutes or so, right?
Awesome, yeah. Let's do it. Thank you so much for this great talk. Looking forward to the second one soon. Yeah, the first, if you want to speak for yourself, feel free to do so. Otherwise, I will just read the questions from the chat. The first question is by Paul. What do you think about a fully agile mindset and remote work? In my opinion, these two ways of working are contradictory.
Why do you think these are contradictory? I actually don't think so. And I actually think that you can work agile while being remote.
Okay, so what I was thinking about is just that what you said about this agile waterfall. I had never heard about this, but it makes a lot of sense, sort of this way of thinking, that as soon as you aren't, connected as directly, you start to, do this again, plan certain tasks in a waterfall style and then just work on those tasks. Everyone works from home, right? And then you go into the next agile waterfall. And while you issue trackers in like open source repositories, in my opinion, are like a prime example for this, actually, that you have these issues, quite big issues, that then one developer tracks, and then, you get to the next iteration. I'm not saying that is necessarily bad, but I just think, this idea of the like perfect agile environment, you need like this as short of communication like lines as possible, and that just works in an office. Like,
yeah,
that's the reasoning.
I completely agree with you on that one. The whole thing with this is, if you are working on an open source project, you often have these issues that you just presented because there's nobody really managing these open source projects. Ideally, if you work in a company, there's people who take care of all the management overhead that remote work brings with it. And this is one of the most important things. This is why also for embracing this DevOps culture, you really need everybody on board, even the management team, because they need to allocate management resources, allocate time and everything. If they don't do, you have a high chance of failing at this transition. If they do, you actually have a good chance of implementing workflows, finding strategies to communicate even remotely.
Okay, so a concrete question, if I may, would
Sure.
be like, how do you watch someone else's screen in, like, I know there is screen sharing, right, in Discord, for example, but like in an office or at a game jam or whatever, it's you get more of this coincidental communication, and hey, look over at this person, hey, I just noticed you were working on that, I had this idea, or you better watch out that you don't or work with this API in this way, like sort of this communication, which can like I haven't found a good tool yet which sort of mirrors this online. Do you have any like ideas there?
I think this actually would include using various tools for different things that we need to reflect from the real world into online. So the first part here, what we use at Freaks for communication is Discord. All of us transitioned from the how do you say, real world office to our Discord remote office. All of us are on Discord all the time that we are working. We do have a focused work channel where people who want to really focus and be concentrated can work. And we do have one channel for each discipline on the team. So for programmers, for artists, for designers. And if you're working on tasks that don't require your full concentration, you can hang out in there and start having these conversations. And I think this is something that requires a good work culture. For us, it worked really well to have the exact same style of conversations that we would have in the office, but sitting in our own workstations in our home offices and just talking to each other remotely via Discord. And this helped us to have the transition to actually leading the same conversations about stuff that we worked on and utilizing screen share to further explain problems just the way that we do in the office. Of course, there's slightly different interactions that you have. You might not have the usual atmosphere that you have in the office, but I think we are getting really close just by using Discord. And then what really helps for us to keep up to date with everything is actually using AppSource as our code review tool, because this requires us to look at each other's work more frequently and do this on a daily basis, multiple times a day, possibly even. So we actually kind of replaced this work that you do manually and in real life by going to your colleague's desktop PC and saying, hey, maybe look at this, by using AppSource and writing these as comments.
Thank you very much. Yeah, that's really interesting, especially AppSource. I didn't know about that yet. We'll definitely check it out. Thanks.
Nice.
Awesome. Do you want directly to continue with your second question, Paul?
Yeah, I just wrote them down while during the talk. I don't know if anyone else wants to go first, because we only have 10 minutes. Then someone else can ask their question first.
Okay, let's do Michael, your question. Talking about meeting protocols, is there a software database for such things, or is it still checkout network drive folder, blah, blah, blah?
Yeah, for protocols, we put them in our Google Drive, actually. So unfortunately, the answer is yes. For us, at least, it's Google Drive. But as soon as we have something concrete, we make some extra work to convert these into Wiki articles. So everything that results as a conclusion or something out of such a protocol is directly being put into a Wiki article. For example, if we have a game design Wiki article about, I don't know, let's say the third level of our game, and in a meeting something about the third level changed, then this is directly being updated in the Wiki.
Sweet. Another question, thanks, he said. Another question by Michael is, are there dedicated test frameworks for game integration tests? I mean, required features might be a bit different from what is needed for industrial software, screen capturing, graphic recognition, maybe, don't really know.
Depends on what engine you're working with. I would say, I'm not sure if Unreal has something, but Unity at least has a test framework, and it wasn't optimal, and it's not optimal yet, but it continuously improves, and they add a lot of features that also help you do stuff like UI testing or graphics testing and so on. I think one thing they introduced recently was a performance testing framework, which you can utilize to benchmark automatically.
Cool. Awesome. Thank you for that. Now, Paul, your question. Is there a project scope from which you would implement your tools, bug tracker, issue tracker, etc.? Or do you think these are mandatory for any project scope?
Yeah, that's a good question. I would actually say they are beneficial to each project, because I know that each project somehow develops into bigger projects than we planned. And as soon as you start something that takes more than 3 months of development or so, you will see the benefits of using these tools. I think even for short-term projects, I actually do this with my private and personal projects. I have an issue tracker in place. I don't always necessarily put in the full pipeline. It really depends. But I really grew fond of, for example, build servers and CI systems, and I use them even in my private tools and projects now. Websites like GitHub, Bitbucket, and so on, they make it incredibly easy and simple to set these up. I know that in GitHub you have these GitHub actions. They are very similar to that. Haven't directly looked into that specifically yet, but having something in place that gives you direct feedback always is useful. And of course, also the other tools like project management and so on, they are really beneficial to your project if you work for it for at least a medium period of time. So not sure how your personal projects are going, but I know that if I work on something privately, this work will usually be distributed over months, and not having something where I can write down my thoughts would be crucial.
Yeah, for sure. I mean, I've been working for my personal stuff with just, Google Keep and just making notes there. And yeah, I have noticed that it can get, it definitely got cluttered. So maybe time for some rearranging makes sense. Yeah. But yeah, I think that there are some projects where I don't think you need all of it. We made an app in like a month, like the other month. And for that, sure. I would say for sure it's not like, it would have just been over engineering.
Of course.
But yeah, there was also another project where I think we could have definitely used it, and it went fine, but it could have maybe gone better even. Yeah, cool. Yeah. Thanks.
Yeah. As I said, I think roughly the 3-month mark is something that should indicate slowly integrating all these processes. As I said, you don't need always each tool. For example, for my personal projects, I usually don't require any monitoring of build stability or something. It's just not of any use for me. So we can kind of grow this with our project, so to speak.